All right, we're going to go ahead and get started on homework number 7, which is called scattered correlation. Scattered correlation. All right, so we're still going to continue the lesson that we started in homework number 6, where we started to use our calculators and we're graphing linear equations. We were looking at strong, weak, negative and positive correlation, as well as no correlation. And we're going to continue learning about that in this lesson here, in this homework assignment. This lesson does require you to graph. I believe each of the problems deals somewhat with graphing. The first few are without a calculator, and the rest of them are with a calculator. So it's important to have a graphing calculator before completing numbers 3, 4, and 5. Numbers 1 and 2, you don't need a graphing calculator for, so you can get started with that. All right, so number one says, make a scatter plot by hand and describe the correlation. And in parentheses, it says no calculator. And then it shows a few tables. And really, it's the same table. It's just broken down into two. If you look at the months, or look at the column headers, month, average temperature, electricity bill, really that's 12 months. So you could just create one table, but it's broken that table down into two, probably just to fit it in there, just so that way it's not taking up a ton of space. So you can actually combine those two tables together. But it says average temperatures and electricity costs, and it lists all 12 months, the average temperature, and then the electricity bill. So what we're trying to see is whenever it is, I guess, depending on the month, whatever the average temperature is of that month, does that have any sort of effect towards the electricity bill? So if you're looking at this, the first thing I'm always drawn to is what is the highest electricity bill? And it looks like $255 is the highest electricity bill that we have here. And it shows that in July, there was an average temperature of 84 degrees Fahrenheit. And then the electricity bill for that month is $255. So I'm also looking, seeing what other numbers. It looks kind of like as the average temperature goes up, the electricity bill goes up. So like June, July, August, and September have the highest electricity bills. And then the lowest look like they come in like December. It jumps up a little bit and fit in January. It goes back down in February. Pretty low in November as well compared to the other months, right? Almost like half of what some of the higher numbers were. So it says make a scatter plot by hand, and the reason we're going to make this scatter plot is to see if there's any correlation, like can we learn anything from this. So I'm going to go ahead here and draw my line, and I just figured out how to do that recently, make my line straighter, which is awesome. And let's see, what should we put here? Let's just say, I really won't care much about the month. I'm going to see if there's any correlation between the temperature and the electricity bill. All right, so average temperature, it looks like there is a gap between, like, the lowest number I see is 58. So I'm going to go ahead and do this in my graph. And that just signifies that I'm dealing with a break, and that up to that point, I really don't have any data. So I'm going to go ahead and make my first point at 50. And this is going to be, right along the side of this, the average temperature, and it's going to be in degrees Fahrenheit. That looks kind of like a P, degrees Fahrenheit. Okay, so if I want consistency, this little break down here just shows, hey, look, there's no numbers before it. I'm not going to create this graph. I'm not going to create this graph and have a bunch of blank space. So as long as I have consistency from here moving forward, then we should be good. So if I like put like a 60 there, and I'm going to move up by 10s every time, consistency is important, right? So I'm going to say that's 80, and I'll say this is 90 up here. I didn't write 40, 30, 20, 10 because there are no average temperatures down that low. So that's why I drew that down there. It really just, what did I do? What is that? That's really just me like drawing some lines saying like, hey, look, you've skipped a little bit. That's pretty standard. All right. And then the electricity bill, I'm going to do the same thing down here because the lowest electricity bill that we see is 110. Is that right? 110. So I'm going to go ahead and say, all right, 100. I'll go up by 20s, right? Maybe I'll do that. Maybe I'll go up by 50s. Yeah, I'll do that. So I'll say this is 150. I'll say this is 200. This is 250. And this is 300. Okay, so, if we were to continue that way, I would have drawn a 50, and I skipped that 50 because there was nothing that low. But this is just so that way we can take a look at this. And these numbers below on the bottom are the electricity bill, and it's going to be in dollars. Okay, so it's important to label, right? This is my x-axis, and this is my y-axis. I have all my numbers along the sides labeled as well. And then also I want to be able to label what we're actually dealing with, right? This actually gives us some information about the data, the naming, the x values as well as the y values. Okay, so we're going to see what the correlation looks like. So let's see here. The average temperature in January was 61 degrees. So I'm going to go up to 61, and then I'm going to go to the right to 150. All right, so I think it's about there. Looks about good. When it is 58 degrees, so I'm going to find about 58, estimate about 58, go to 139. Let's say, maybe about there. Okay. And then we have 67. So I'm going to find 67. That's over here. Right, 67 and 172. 67 and I'd say about there. Okay. And 75 and 205. 75 looks like about there. And 79 and 170. So 79 a little bit higher. And 170 is about right, I don't know, I'll say about here. Doesn't have to be perfect. And then 79 and 170, so 79 up here. Let's go to the right. 170, that's around the same spot. 75 and 205. I guess we just did that. I'm losing track of it. 83 and 234, which is June. 83 and 234 is about, I don't know, probably like right there. Maybe I'll move it up a little bit. 83, maybe move 83 and 234. I don't know, maybe we'll say like right there. Okay. 84 and 255. 84 is up there and 255. That's going to be about, let's just say here. 85 and 245. That looks about 85, 245. I'll put another point right here. 81 and 210. So 81 and 210. 81, 210 looks like about right there. Doesn't have to be perfect. Just try and get it close. 76 and 183. 76 and 1. I'll do. So we got a point almost right there, so I'll put it right next to it. 65 and 132. 65 and let's say 132. And 58 and 110. So 58 and let's see about right there. Okay? Doesn't have to be perfect, but a few questions that you could ask me are, well, why would we choose to put these values on the left and these values on the right over here? Why would we choose to actually have the average temp going up on the left or on the right? That could change. It's totally up to you how you want to graph it. But either way, what you're going to sense is that there is a correlation, and you're going to realize that in this case, it looks like there is a very strong positive correlation. You see how all these are going up, right? So if you look on your homework, it describes at the very top of homework 7 what strong negative correlation looks like, what weak negative correlation looks like. This looks pretty strong. This is our set of points. And even though they're not 100% perfect, I can sense that there's positive correlation and they're pretty close. So maybe something that I can say or something that I can conclude from this strong positive correlation, something that I can conclude from this is that as the temperature goes up, the electricity bill goes up. Okay, maybe throughout the summer you're running your AC a lot more. Maybe throughout the winter you turn the heat not as high and you aren't using the heat as much, and whoever's electricity bill this is, maybe it could be the opposite. Maybe someone lives in a colder climate and their electricity bill looks entirely different, where in the winter it just goes sky high. In the summer they have a mild winter or mild summer, and they're able to they're able to keep their electricity bill low. So in this data, things it doesn't tell you. It doesn't tell you where this is. This is only 1 year of data. This also doesn't take into effect some outlying considerations. But with that being said, I think this either way shows that we do have a positive correlation, and it is pretty strong. A lot of these points are very closely tied together. Okay, so that's what I want to see on the graph, is that I'm not looking for all these points to be perfect. I want you to go through and plot these points, see about where they're at, and then move from there. So once again, just to recap, these things in the graph, those just show that I skipped a little bit of the graph just to get to the part that matters. I could have drawn a graph that looks like this, right? And all my points be like way up here, and skip this whole portion of the graph where there's nothing there. So what I did was I said, hey, look, I'm just going to focus on this instead. And by doing that, I skipped it. That little almost looks like a heartbeat, moving up and down. That's just me showing, hey, look, I've skipped a little bit, and now it's focused on the part that matters. Okay, so there's nothing wrong with that. That's pretty standard here, and what is going to be allowed in this Algebra 2 class. All right, so that's number 1. Number 2. Number 2 says, make a scatter plot and draw a trend line by hand, no calculator. Same directions as, actually not the same directions. It says draw a trend line. So I'm not describing the correlation. I'm going to draw a trend line. So let's go ahead and do that. All right, so I'm going to go ahead and draw my line. That's going to be my y-axis. And this is going to be my x. I'll go ahead and make sure my line is labeled. Whoops. What am I doing? That's my x-axis. And that's my y-axis. Okay. So from here, it looks like it says California median home prices. Okay, so they took all the home prices in California in this year, and I just trust this to be true because it says so in the math book, but they took all the prices of all the houses in California and they found the middle price. That's what median is. What's in the exact middle? Median is different from mean or average. It just means you take all these numbers and find whatever number's in the middle. So it says the year is 1940 and the median price is $36,700. Wow. And then in 2000, the median price, not average, is $211,500. Wow. That's a big difference. So I guess what we're going to be recognizing is as the years go on, it looks like the prices are going to go up. So every 10 years, we have 1940, 50, 60, 70, 80, 90, and 2000. There's no data for 2010 or 2020. All right, so we're going to just use this and move forward. So I'm going to go ahead and across the bottom, that's what my choice is. I'm going to go ahead and say 1940, 1950, 1960, 1970, 1980, 1990, and 2000. And the label for this is just going to be year. Now, it is a best practice to put that in quotation marks, and I should probably go back and put these top two in quotation marks. Okay, typically that's what they want to see. Whenever you're looking at a graph, you might see that in quotation marks. That's just saying that's my label. Okay, so I went back and did that. And then over here, we'll have median price, and I'll just say in dollars. Okay, and let's see, it ranges from 36,000. So maybe I'll just do 50, 100, 150, 200, 250. Yeah, let's do that. So I'm not going to skip any on here. I'm just going to go. I'm just going to use a K at the end. I'll say 50K. 100K. 150K. 200K. And 250K. K just stands for 1,000. All right. So looking at this graph, and I'm starting in 1940. I don't have the data for 1930 and below, so I'm not even going to recognize that. All right. So moving on. 1940. Looks like the home price was around. The median price was $36,000. That's crazy. So I'm just going to go ahead and put that there. 1950, let's see, 57,900. So it's going to be about, I don't know, what to say about there. And in 1960, 74,000. So, I don't know about there. In 1970, the price was 88,000. So getting up there. In 1980, the average price, it jumped in 10 years. It doubled from 88,000 to 167,000. That's crazy. Let's go ahead and put that about there. In 1990, it jumped again. Everyone, I guess, was moving out there. In 1990, goes up to 249. All right, that looks good about there. Well, let me move it down a little bit. right? It doesn't have to be perfect. And then the year 2000, 211,000. Wait, it dropped a little bit. Oh, wow. Look at that. I didn't even realize that. 2011. I wonder why it dropped. Okay, so if I were to draw a line, I guess that's where I'm at right now. Just make a scatter plot. Did that. So let me make my checklist here. The first thing I want to do is draw a scatter plot. And the second thing I want to do is, it says draw a trend line. So my trend line is going to be an estimated line that I feel like goes through, I guess can predict what the future might look like. And based on the small sample set of data that we have, it's pretty weak in correlation, meaning that I don't have a lot of data. It's just kind of spread throughout, especially over every 10 years. If I had it every 6 months or every month, or, there'd be a lot of data on here, but I don't have a lot. So I'm going to pick a trend line. I'm going to start it at the very bottom of the screen. And I'm going to draw it starting at 0, 0. And, I said I'll start right here. I'll start right where and I'll draw a line. I'll straighten it. Let's see, probably about, I don't know. That's my trend line. And what I did was I just picked a line that I felt like went through the average of my points. You may have picked a different trend line, but that's kind of what I saw. There's no right or wrong answer in this. As long as your trend line looks like there's some sort of positive correlation. If your trend line was way over here, that would be a problem. Or if your trend line was I don't know, up here, or flat, or completely going in the wrong direction the other way, that way, then there would be a problem. But as long as I see that you've tried to draw a trend line and it's pretty straight, maybe use a ruler or the side of your paper, I think that's important. Okay, so this is my trend line. I'm just going to label it, and that's what I see. Okay, whenever you see trend line or line of best fit, it's the same thing. Line of best fit. The line of best fit is usually more calculated with a calculator, and that's what we're going to use in the next example. But you can draw your own line of best fit without a calculator. Okay, so that's what I have for number 2. All right, I'm going to go ahead and get started on number 3. And for numbers 3, 4, and 5, we are going to need to use a graphing calculator. Recommended that we use either a TI-83 or a TI-84. So with that, if there are any questions that you have about your calculator, please let me know. Please don't wait till the last minute to let me know that there's maybe some different procedure in order to do this in your calculator, that you tried it and it didn't work. Let me know as soon as possible, and I want you to follow these steps in this procedure pretty carefully here, and it's going to be very similar to what we did in the last homework. So with that being said, the directions for number 3 say find the line of best fit, use a calculator, take a picture of your calculator showing your graph, and attach it. Okay, so first thing I'm going to do is I'm going to turn on my calculator, and if there's ever anything I don't know, anything that's in your calculator already, just click up here in the top right corner where it says clear. Just clear all that out. We don't want anything in there to start out. Okay, so the first table that I get says studying hours and test score, number 3, and it lists number of hours, and it says, all right, so I'm guessing the number of hours studied was 8, and the test score was a 75. The number of hours studied was 5, and the test score was 62. So we're looking to see what the correlation is. The reason why we make graphs and the reason why we like to look at data is to gain further information about what was actually done, or to be able to predict something in the future. So, if I'm able to see that the the person that studied for 14 hours got a 95%, and the person that only studied for 2 hours got a 35%, maybe that means something, that the more hours that you study, the more time you put into something, the better that you get, which is pretty true for a lot of things. If you are really not distracted and studying, or not distracted and focusing on something, usually throughout that period of time you get better. So not in every case, but at the same time, like, this is just some of the data that has been collected for this problem. So for number 3 here, the way I'm going to start off is I'm going to enter all of this data into my calculator, and I'm going to click this stat button, okay? And I'm going to edit whatever stats I already have in here. So I'm going to press enter, and it looks like I still have numbers in here from my last example. So I'm going to go through, and the way I clear out this entire list, all the values here on the left are all my X values. And the way I clear all them out, I can go up to L1, which stands for list 1, and click clear and click enter. And that clears out my entire list. And do the same thing for L2. Go over there, highlight L2, click clear, and then press enter. All right, so I'm going to go ahead here and I'm going to enter my X values, which I'm just going to use as my number of hours. So I'm going to type in 8, 5, 12, 10, 2, 9, 11, and 14. And if you're wondering where I got these numbers from, they're right here from the homework in number 3. Okay, so now I'm going up to the top, and I'm going to make sure my score percentage lines up. These are my Y values. So I'm going to type in 75, just in the same order, 62, 80, 85, 35, 70, 82, and 95. Okay, so make sure that all your values line up, right? I'm going up to the top again. I'm just going to go up 875, 562, 1280, 1085, 235, 970, 1182, and 1495. If those numbers don't line up, then that's a problem. Okay, so that's all my data. I'm going to click on Y equals, because this is where I'm able to actually graph things. So I click on Y equals. I'm going to clear out, if there's anything in there already, I'm just going to clear it out. All right, I don't want that from the last, I don't know, maybe I did a problem before and that number's still in there. Clear all that out. And then in the top left corner, make sure plot 1 is highlighted, right? So if I click down below, notice how plot 1 stays like highlighted in black. If plot 1 looks like this, then that's a problem. Notice how plot 1's not highlighted right now. So click plot 1 and click enter. And if I were to move down, I could see that plot 1 has now been selected. Now, when you graph it, your graph might not look the way you expect it to look, which is fine. So what you're gonna have to do is, right now it's zoomed to a certain zoom. I wanna be able to change where I'm gonna zoom in to show my points. So I click up here where it says zoom, and then I scroll down to 9 for zoom stat. I wanna view all the stats. Remember right there, all the stats I entered? I wanna be able to zoom to just see them. And if I click enter, I see all my points, right? So in numbers 1 and 2, I like estimated and put those points, and I did a poor job of doing that. This is exact, and that's why I love the calculator, because the technology allows us to be very exact and precise. Okay, so it looks like with this trend line, it looks like we have positive correlation. And when there's positive correlation, that means that as the number of hours that you study goes up, your score percentage typically goes up as well, okay? Obviously, that's not always the case, so it's not a straight line, but the same, not like, hey, for every hour you study, you're gonna get 10 points on the test. That's not always true, okay? So now that we have this data, it asks us to find the line of best fit. And here's how I would do that, okay? I'd click on stat right here, and we already entered all our stats, but we're gonna calculate something. So I'm gonna click here on the right button to go over to calculate. You see at the very top, calc is highlighted. And I'm gonna go down to to where it says linreg for linear regression. Just think of that as I want to draw my line. I want to draw my line of best fit. So lin, just think of as your line. So I'm going to go ahead and click that. Now, that being said, when you click that on some calculators, this looks a little differently, but you're still going to do the same exact thing. And if you have questions, if you have a different calculator, please ask me and I'll show you how to do it specifically on your graphing calculator. But from here, what I'm going to do is I'm going to click vars. No, don't click anything past here. So click vars for variables. I'm going to go down to my y variables. I'm going to graph a function. And I'm going to put it in y1, which was the very first one. If I clicked on y1 or y equals up there, y1 would be my very top graph. I'm going to click enter. Click enter one more time. And when I've done this, what I've done is it gives me the equation right here. It automatically put it in y1. You see how y1 is right over here to the left, right? It automatically put it in y1, and if I click on graph, it graphs my trend line. In this case, my line of best fit is what it's called. So remember in number 2, I went ahead and just drew my own line. This line is precise, okay? And this shows positive correlation. So what you would do is you take a picture of this and then move on to the next one. All right, so that is number 3. Make sure you take a picture of your graphing calculator, not my graphing calculator, showing that you know how to do this. All right, so let's move to the next one, okay? We're gonna go ahead and start over. So I'm gonna go and click Stat. I'm gonna click Edit. I'm gonna clear out List 1. I'm gonna clear out List 2. And I'm gonna move a little bit quicker, not super fast, but a little bit quicker now that we've understood some of this. Number 4 says fast food calories, right? That the number of calories and grams of fat. All right, so I have like fast food, restaurant A, restaurant B, restaurant C, and so on. All right, so number of calories, I'm gonna say 720. It's the first number, and then 530, 510, 500, 305, 410, 440, 320, and then 598. Is that what it says? Yeah, 598. All right. Click to the right here. Make sure 720 lines up. Yep. So and I'm going to do 46, 30, 27, 26, 13, 20, 25, 13, and 26. Okay. All right, so I've gotten this far. Now, if you remember what we did last time, I went ahead and made sure that anything that was in this Y1 is cleared out. That plot 1 up there was highlighted. That I click graph. None of my points show up, so what do? I click on zoom and then go down to 9. I can just press 9 right here if I really want to, or I can scroll down. If I just press 9, it automatically does it for me. Okay, so that's a little shortcut. So now that I've done this, I see there's some sort of positive correlation. Let's draw my line of best fit. The way I would do that is I would click Stat, go over here and go to Calc, go down to Linear Regression, click Enter. Now I want it to be stored in a variable. Click on vars, click to the right one. Now I'm in function, click Enter. Click on Enter again for Y1 and click Enter one last time. It gives me the equation. It automatically puts in my Y equals for me, and it graphs the line for me. And then you take a picture of it, right? Once you learn the procedure, it makes things so much easier, right? It's just being able to actually learn the procedure. Okay? So with that, I'm going to go ahead here and I'm going to, whenever you want to go back to your main screen, you hit second and then see where it says quit right there. I can just go back to my main screen. I'm just going to clear everything out again and I'm going to go to stat. We're going to move on to number 5 here. I'm going to enter my stats in here. I'm going to speed through this one because we've gone through the same procedure now for the 3rd time. So I'm going to clear out my L1. I'm going to clear out my L2. If you don't know what I'm doing, then please go back to the previous examples. Okay, 1998, and then we have 2000. I'd like for you to try this on your own too. Like if you're just following my steps for the first few, that's okay, but eventually you're gonna have to do this on your own to see if you can make it work. If it doesn't work, you can always go back and double check against what I did, okay? 2008. All right, if you ever come across any problems, let me know, and then I'll be sure to help you. 2.65, 2.89, 3.00, 3.01, 3.20, and it's okay, like 3.00 came out as 3, if you see right there, that's fine, it's the same number. 3.20 came out as 3.2, that's fine, it just will automatically round for you. 3.77. Okay, all those line up, everything looks good. So what I'm going to do is I'm going to go to my y equals, I'm going to clear out the line from before, make sure plot 1 is highlighted at the very top left, click on graph. I can't see it, so I'm going to go to zoom 9, or you can go and scroll down to 9, right? Click enter. Those are my points. Let's draw our line of best fit. So what I would do is I'd go to stat, click over to calc, go down to linear regression, just think I'm drawing my line, so lin for line, click enter. Now I'm going to store it as a variable, click vars, click to the right, I know it's going to be a function, be in y1, click enter again, it gives me my graph, it gives me my equation, the equations are already put in there for you, and it graphs my line. Okay, so that's number 5. Now that you know how to graph through 3, 4, and 5, you're good. And we'll be learning a lot of things with our calculator this year. That's why I stress so many times to bring your calculator to class, because some of the stuff cannot be done without a calculator. It helps make our lives easier. Technology is meant to make our lives easier, not to make it more difficult. I know that sometimes technology can be overwhelming and you can maybe use technology for the wrong reasons, but that's not the purpose of technology. Technology is meant to help us. So if you have any questions, please let me know, but that is homework number 7.